We have a ball rolling horizontally over a table or a tall shelf. It's 3 meters high off the ground. It's rolling with a horizontal velocity of 2 meters per second. It's going to be arcing down in this parabolic path, and we want to find out what the range is. The range will be delta x. There are 2 steps to this. First of all, find how long it's in the air, and secondly, then an equation to find the range. The time in the air is dependent upon only the height of the fall. The speed here that's moving horizontally does not affect the fall time at all, only the height. It falls with the exact same time as if something was just simply dropped straight downwards without any arcing path at all. And so we use the same equation as we did for dropping objects. T equals square root 2h over 9.8. Remember, the 9.8 here is the positive version of gravity because the negative signs canceled out when we made this equation. So the h is the only thing that we're going to change to a number, and that's the 3 meters of the fall. 2 times 3 divided by 9.8, square root the whole thing, and we get 0.78 seconds for the time of fall. The second step then is to find the range, and we have a very short equation to solve for that. Delta x, or the range, is equal to Vx, the horizontal rolling velocity, times the time in the air. The stray problem gave us the 2 for the velocity. We just figured out the 0.78 in the previous step. Multiply those 2 together, and you get 1.56 meters. In the next problem, it's going to be very similar, but the second step is going to have a little twist to it. We have here a car that's going off of a cliff. It's initially going horizontally at an unknown velocity. It's going to make this arcing path, and it's going to land on a boat, and that boat is 12 meters away from the cliff. We know that the cliff is 9 meters tall. So in this case, we know the range. We want to find the velocity. The equations, though, that we're going to be using are the exact same as we did in the previous problem. The first step, find the time in the air. And we use the time to drop equation for that, 2h over 9.8 in the square root. The height of the cliff, once again, is 9 meters, so we put that in for the h. Square root of 2 times 9 divided by 9.8 gives us an answer of 1.35 seconds. The second step, we use the same equation as we did before to find the range. It's just that in this case, we are looking for the Vx, the horizontal velocity. We know the range, delta x, in this problem. We were given that the range was 12. We just figured out that the time in the air is 1.35 in the previous problem. So in this case, we're going to divide both sides by 1.35. In your calculator, type 12 divided by 1.35, and you should get 8.89 meters per second. The next problem is very similar to what we just did. It looks different, but the math is going to be the same. We have 2 buildings here separated by a gap of 20 meters. The left building is 19 meters tall, the second building is 12 meters tall. We're throwing a ball horizontally, and it's going to arc down and just make the gap and hit the other building on the top. We want to know, how fast do we have to throw it? Again, the first step is to find the flight time, using the same equation. Now, the height here, though, is not the height of the second building. It's not the height of the first building. It's going to be the height of the fall. And it is only falling from this height up here to this height here. That's all the falling that's happening. So we have to take the difference between the 2 heights. The difference between the 19 and the 12 is 7 meters. That's how high the fall is. And so We have 2 times 7 divided by 9.8, square root it, and you get 1.2 seconds. The second step is to find then how fast it has to go in order to make the gap within that 1.2 seconds. Find the velocity. And we use the same equation as we have been. Delta x equals vxt. We're looking for the vx. The delta x is the gap between the buildings, which will be 20 meters. The time we just figured out, 1.2. It has to make 20 meters within 1.2 seconds. So you divide both sides by 1.2, type in your calculator 20 divided by 1.2, and you get 16.7 meters per second. Next, we have angled projectiles. So we have a motorcycle going up a ramp that's 40 degrees. The launch velocity of the motorcycle is 20 meters per second. We want to know how far it's going to go. What is its range? The delta x. Now, in this case, we can't use the same equation as before. The previous equation with the square root 2h over 9.8, that is used only for dropping downwards from a known height. In this case, we have the object going up and then down. We don't know how high it's going to get, and so it's going to be a different equation. In order to figure those things out, the first thing we need to do is to find the velocity components, the x and y components of the velocity. The vx here, that is how fast the shadow moves across the ground, how fast it's moving horizontally. And we find that by multiplying the launch velocity times the cosine of theta. In this case, the launch velocity is 20. The theta, the angle of the ramp, is 40. Multiply that correctly on your calculator and you get 15.3 meters per second. Make sure that your calculator is in the degree mode. If you have a grapher calculator, you're going to be typing in 20 times, and then the cosine button, and then the 40 button, and then enter. If you have a less complicated calculator, most likely you're going to type in 20 times, and then the 40, and then the cosine button last, and then equals, and you should have 15.3. Once again, make sure that your calculator is in the degree mode. Okay, that's the horizontal velocity component. Now, the vertical velocity component. This is how fast the altitude is changing as it goes up and down. We find that by multiplying the launch velocity times the sine of the angle. So it's going to be 20 times the sine of 40, gets to be 12.9 meters per second. Okay, now we're going to be using the y component in the next step to find the time in the air, because the faster it's rising in altitude means the higher it's going to get, which means the longer it's going to be in the air. So this we use to find the time in the air. We're going to be using the horizontal component of 15.3 to figure out how far horizontally it flies during the flight time. Okay, so second step, find the time of flight. There's two ways of doing it. One is using the equation VF equals VI plus AT. The VF is the final velocity up and down, which is going to be downwards 12.9. And then the VI is the initial velocity upwards, positive 12.9. The acceleration, the change in these velocities, is by gravity, so the acceleration is negative 9.8 times the time. To solve for time here, the first thing you're going to do is subtract off 12.9 from both sides. So you're going to end up with negative 25.6 on the left-hand side. And then we're going to divide both sides by negative 9.8. Your final answer is 2.6 seconds in the air. Remember, to find the flight time, you only use the y components. Another way of doing it is the shorthand version of the equation. Time in the air is the y component divided by 4.9. So you just do 12.9 divided by 4.9, and you get 2.6 right off the bat. No algebra needed. The third step, the last step, is to find the range, and we use the same equation as we have the entire assignment here. The delta x is what we're looking for. The Vx we found in the first step, 15.3. The time we found out just a moment ago, 2.6. Multiply those together, and you get 39.8 meters. Last one. We want to find the range of a rocket that is launched at a 70-degree angle at a speed of 50 meters per second. We want to find the delta x range. The process here is the exact same as what we just went through. First step, find the x and y components of the velocity. So to find the Vx, we multiply the launch velocity times the cosine of the angle. That's going to be 50 times the cosine of 70. Gets us 17.1 meters per second. Make sure that you can do that with your own calculator button pressing. Vy is going to be found by multiplying the launch velocity times the sine of the angle. So that's going to be 50 times the sine of 70. Sorry about that. 50 times the sine of 70, which is going to be 47.0 meters per second. First step then, find the Vx and Vy. Once again, we find the Vy in order to use it in the next step to find the time in the air. The Vx is used in the last step to figure out the horizontal distance, the range, the displacement. Okay, so second step, find the flight time. Use the equation Vf equals Vi plus At. The Vf is the negative version of the y component. It's coming down, so that's going to be negative 47. The initial velocity is going upwards, positive 47. Acceleration is always by gravity pulling down, negative 9.8, times the unknown t that we're looking for. Solve for t here. The first step, subtract off 47 from both sides, and then divide by negative 9.8. You get 9.6 seconds. Another way of doing it is using the shorthand version, the y component divided by 4.9, and you get the same 9.6. The third step, find the range using the same equation as we always have been. Delta x equals Vxt. The Vx is what we found out on the very first step, 17.1. The time we just figured out at 9.6. Multiply those together, and you get 164 meters. That's it.